Hello, I'm Malcolm Groves, and in this session I want to give you an introduction to MVVM, Model-View-ViewModel in Delphi. Here's the rough agenda. We're going to talk about the problem we're trying to solve and a couple of different approaches to solving it, then drill into Model-View-ViewModel and talk about the component pieces. We'll walk through an example, simple example application and look at some common problems that you strike. Talk about a few more things to think about when you're starting down this MVVM path, and then look at some more resources. Broadly speaking, if you break up the logic inside an application, you can put them in the three buckets. Your presentation logic, in terms of what your form is doing and what controls are presented to the user at any particular time. Your domain logic, the logic of the actual problem domain you're trying to solve, and also your data access logic, how you talk to the database, how you save things, how you load things, where you put all of this logic in your application, and how you separate all of this logic from each other in an application matters an awful lot. And a lot of effort and time has been put into this over the years, into how you break an application down into these different areas. If you think about the traditional Delphi approach to this, for want of a better word, I couldn't think what to call this approach, the RAD approach to this, these three areas of logic tend to end up mixed together in a lot of cases. They don't have to, but they often do. Your data access logic might be mostly separated off into data modules, but some of it leaks out into your forms in data source events and those sorts of things. Presentation logic tends to be mostly in your form. Domain logic tends to be spread across both of those places. But most importantly, they tend to be mixed together. So a single event handler, for example, might deal with some presentation logic, make some domain logic decisions, all wrapped up in adjacent lines of code. This has some advantages, of course. Applications like this that take this approach tend to be quick to develop. That's the whole point of RAD, rapid application development. So you can start building things quickly. But what tends to happen, unless you're very careful, is that speed of development tends to slow down the bigger the application becomes. But another advantage of this approach is that it tends to be well understood. If you hire a Delphi developer off the street, chances are they understand this approach to building applications. Some definite disadvantages, though. It fairly quickly becomes hard to maintain and brittle. Changing some aspect of your presentation logic impacts on changes in your domain logic, for example. It's definitely hard to test because your domain logic is all mixed in with your presentation logic. It's hard to unit test that domain logic because you can't isolate it. And it's definitely what's becoming more and more of an issue now since Delphi has gone cross-platform, is it's hard to replace one UI with another without having to rewrite a lot of that presentation logic and domain logic, because they're all mixed in together. So if you want to slide your Windows UI off your presentation logic and replace it with an OS X UI, or with Mobile Studio with a mobile UI, that becomes hard, and in some cases it becomes a case of rewriting. So this is not a new problem. Things like MVC, Model View Controller, which you might have heard about more recently from the web world or from Objective-C and the Xcode world, has got a lot of attention. There's a thing called Model View Presenter, which was a pattern that came up trying to deal with some of the perceived problems in MVC. MVVM, in turn, was another pattern, and the one we're going to talk about today, which evolved to try and leverage some more modern UI capabilities like data binding. The core thing about MVVM is that it focuses on the presentation layer. MVVM has nothing to say about the data access layer, and it has very little to say about your domain layer. Even though model appears in the name, it's got very little to say about how you should build your model. It very much focuses on the presentation layer. The blue arrows here indicate who knows about what. Of dependencies, if you want to say. So your model knows about nothing except your model. Your view models know about the model and other view models, but they know nothing about the views, the actual forms in your application. In turn, the forms tend to know about everything. So there's a nice clean separation. You can change your views and it doesn't impact your model and it doesn't impact your view models because neither of those know about your views. And as I mentioned or hinted at before, LiveBindings is used to tie your views to your view models. Let's talk about each of these areas in a bit more detail. Your model is your domain model, like I talked about before. It's the model of your problem domain. So if you're building an iTunes competitor, your model will be all about artists and songs and plays and ratings. If you're building an accounting app, it'll be about accounts and transactions. It's non-visual. It's a domain model, but importantly, because it's non-visual and hopefully you are architecting it nicely, it can be unit tested. Yeah. Your view model is literally the model of your view or the model of your UI. For a form, for example, this would be a model, non-visual, but a model of all of the logic represented by that form, but also all of the data represented by that form. So the UI rules, the workflows, and the processes that a user might interact with in that form are all modeled inside your view model. Because it's non-visual, it knows nothing about edit boxes and buttons and forms. It knows about state and it knows about processes. View models can also be unit tested. The last piece is your view, and this is actually the visual rendering of a view model. So this is where you have edit boxes and buttons and forms, and basically inside your view you use LiveBindings to bind the state, the data in your view model and display it inside your view, and you have the minimum code needed to invoke the methods inside your view model. The key thing to realize is that because views are visual, they are hard to unit test, and so as a result a general goal is to keep the amount of code in a view to a minimum, and what code is in there should be super simple, because this is the one part of the three sections of our application which is hard to unit test. So if it's hard to unit test, keep it small and keep it simple. So that's MVVM at a high level. Let's drill in to an example. I've got an example application called Menial Tasks. It's a simple task management application. It's focused on introducing MVVM and nothing else. And I've kept it purposely simple. It's just got the bare minimum number of features that I needed to show some key MVVM topics. There's no persistence, there's no inversion of control. I'll talk about that, why that matters later on. It's purposely simple. Before we start diving into the source code, let's begin by running the application so you can get an idea of what it does. The first thing you'll notice is that this is not a session about creating attractive user interfaces. This is very functional, very simple, keeping the focus on MVVM. There are other sessions during CodeRage on FireMonkey and styling and whatever else you like. What we have is a simple task application for managing tasks. You can see here we have a list of once we create some, we will have a list of tasks. We have some buttons to let us navigate through the list, and we have a button to let us create a new task and edit an existing task. So let's do exactly that. Let's create a new task. A child form comes up. We can give it a name or a title. Set details about when this task is due and some more details about the task. Okay, and we can save. Let me create another task. Same thing again. We've now got 2 items in the list. You can see as we navigate through them, we can see the details over here. If we want to edit an existing task to change something about it, we can bring up that same child dialog, but in this case it's loaded up with the task we want to edit. We can make some changes to the details, but importantly, if we click save at this point, the changes will be saved. If we click cancel, they'll be discarded and the current values will be retained. Okay, so that's what I'll do. So very simple, but it gives us a few key things to look at when we're exploring how MVVM works. So let's actually have a look at what we have in terms of source code. First, let's look at this guy. This is a package. You don't have to use packages in MVVM, but in this case, I'll explain later why I'm doing it. But in this package, I have all of my model and my view models. Okay, so this is all of the non-view code in my application. You can see in my model I have things like a unit which contains my task, which is just a class. Nothing terribly surprising in here. It's got a string property called a title, a string property which is my details, a date time which is my due property. We'll have a bit more of a look through some of the source code in here later on. We also have a task list, which is just also again a class. Has a few properties like count and exposes some functions to add a new task and to test whether it contains a task. Again, we'll come back and have a look at in particular one thing about this class, but you can see here it just ultimately is a class that contains an object list, a T object list of T task called F tasks. Yeah. So again, nothing terribly surprising there. If we have a look in our view models, we have basically a main view model which maps to our main view, our main form, and we have a task view model which maps to that child form that was popping up to let us edit and add an existing task. Let's have a look at this guy. Let's look at the task view model. If we bring this up, again, it's just a class, just an object. Yeah, there's nothing visual. It doesn't descend from form or panel or anything like that. And you can see it has some properties. It has a property which is a task, so it's exposing part of our model at this point. And it has a property about a Boolean property called canSave. We'll come back to that. It has some methods, save and cancel. Let's also have a look at our main view model. And again, it's just a class, nothing visual. Has a constructor, has a property which is a reference to our task list from our model. So again, the view model is responsible for exposing just the relevant pieces of our model to our views. Yeah. We'll come back and have a look at this in more detail. When we go up to our exe, which, if you have a look, which uses that package, basically all it contains is a couple of views, a main view and a task view. So let's have a look at our main view. Looks familiar, looks like that form we were looking at. What we have in here though is really just the pieces that are related to this particular visual representation. Okay, if we look at the source code, our view main, which is a descendant from a form, has a reference to a view model. See this private field called fViewModel, which is of type tMainViewModel. Well, as we saw before, that's our viewModel class. Okay, so my form has a reference to its corresponding view model. Notice that while the form knows about all sorts of user interface type stuff, there's FireMonkey units in here, that sort of thing, data binding, LiveBinding units, and it also has a reference to our view model here, viewModel.main. If you look at the source code for our view model, have a look in the users clause. The only thing in the users clause are references to the model and to other view models. There is nothing in the users clause. There are no dependencies from our view model back to our view. Okay, and if you go one step further and actually look in our model, so here's the model, here's the model for our task. The only thing this has dependencies on, or the only thing it knows about, are some system units and other parts of the model. Yeah, same in our model task list. It knows about other parts of the model, but it doesn't know anything about view models. It doesn't know anything about forms. So there's a really clear separation. So let's have a look at a couple of things. First thing I want to look at is how the LiveBindings exposes the data in our view model inside the view. Okay, and if you've done any, if you've watched any LiveBinding sessions, or if you've played with LiveBindings or seen it at an event, this won't be a massive surprise. So if we focus just on the, let's focus on that child form. So our view model, our task view model, has some data to display inside the task, and it has some behavior. So let's focus on the data. If we actually have a look at the corresponding view for our task, you can see it's got a couple of things. It has an action list, which we'll come back to later on, and this guy is our bind source. It's actually a prototype bind source, and if I bring up the object inspector and have a look at the field definitions in here, I've created in my prototype bind source, I've created 3 field definitions. A title, which is a string, a due, a field called due, which is a date time, and a field called details, which is a string. Okay, so if you've looked at the prototype bind source, this just gives me design time fields to bind from. Okay, if we actually bring up the LiveBindings designer, you can see that those fields, title, due, and details, are mapped to the corresponding visual controls here. So again, no massive surprise. The last thing that we're doing in my bind source is in its, because at design time it's using the prototype fields, at runtime I want it to not use the prototype fields but instead refer to my view model. In the onCreateAdapter event, what I'm doing is creating a bind source adapter which is of tObject bind source adapter of type tTask, and what I'm passing into this call to create, the owner is the bind source. The instance that I want it to actually point to, the instance of tTask, is the task contained in the view model. Okay, and we can see here I've got a method in here called viewModel, which simply returns my tTask viewModel. So I'm saying viewModel.task is the instance that I want it to bind from, and because the names of my fields in my prototype bind source map to the names of the fields in my viewModel, viewModel task, here we go, title, details, and due, those bindings at runtime work. Okay, so very simple from a LiveBindings point of view. The next thing I want to show in the example, or talk about in the example, is how we've just looked at how the data is bound from our view model into our view. The next thing I want to talk about is how the methods are called, how actions are invoked from the view to the view model. It's not terribly complex or even surprising, but it does offer, I think, a really clear insight into the separations between view and view model. So let's really briefly jump across to some slides on this. I'm using actions. You don't have to, but just like actions in a normal Delphi application provide some nice features, they do in an MVVM application as well. But basically we have 3 actors, for want of a better word, involved in this example, and the example I'm going to use is the save button. In our view, in that child view that we were just looking at, we have an action list, and I'll show it to you in the source code in a second, and one of the actions in it is the save action. As you would know from an action list, you typically have an onExecute and an onUpdate event for each action, and in the case of the onExecute, it's really simple. My onExecute event simply calls the save method of my view model. Okay, so super simple. Let's just jump across quickly and have a look at that. Here's my task view. Okay, here's my action list. The save action, or the save actions on execute event calls viewModel.save. Okay, so nothing terribly surprising there. The other part of it, though, I think is more interesting. What happens on the onUpdate event of our task, and this is where the form can decide how to represent the state of the save action. So is it currently enabled, disabled, that sort of thing. What this is doing is calling or referring to the canSave property of our view model, okay, which in this particular case is then talking to the task, which is part of our model, and querying to see if the task is currently valid. So it's validating the task, the information we've put in. If it's valid, it's returning true. If it's not currently valid because it's missing some piece of information, it's returning false. Okay. The view is then deciding what to do with that information, and in the case we'll look at, it's disabling or enabling the action, and in turn disabling or enabling the button. But I think this is really nice because it clearly shows that the view model is making the value judgment about whether, given the current state of the view model, whether it logically could save now, whether save is a valid action at this point. Yeah, the view model is not making any decision about whether how that's represented, about whether there's a button attached to this and it should be enabled or disabled. None of that. It doesn't know about buttons. All it's saying is, given everything I know about the state of this view model at the moment, save would be valid. Okay, the view takes that information and decides how to represent that to the user. So in this case, disabling the button or enabling the button, as it might be. So how that actually appears in source code, we can see that in our view model, here's our property canSave. The getCanSave method is just returning whether our task is valid. And in our model, where the task live is valid is pretty simple from memory. Get is valid is just returning whether there's a title or not. Okay, as the note I've made here says, you know, your validation should probably be richer than that. But in this case, we've decided that a task is valid if it has a title. Yeah. So my view model is saying I can save if my task is valid, if my task has a title. My view, on the other hand, takes that information here in my onUpdate event of my action and says, well, if the view model says I can save, then I will enable the action. If the view model says I can't currently save, I'll disable the action. Yeah. So nice clean separation, very clear who's responsible for making what decision. The view decides how the state is represented. The view model decides what the state is. The next thing I want to talk about is displaying a child form. Because for two reasons. Number one, unless you've got a really simple application, you're going to have multiple views or multiple forms. Second is it really fundamental. It's a fundamental decision about keeping these separations. I'll talk a little bit later about this debate about versus view first versus view model first. But for now, just think about the fact that our view model, in my case, the view model is making decisions about when things should happen, because that's where all the logic of my view lives. And so it needs to make the decision that now it's time to display a form, a child form to the user. But at the same time, remember, my view model doesn't know anything about the user interface. So I don't want it to actually create a form and display it to the user, because that would break that separation. So we have this interesting problem of how does my view model basically display a child form and then get the information out of it, while at the same time knowing nothing about the child form and even which particular view might be used to represent it. So at its core, this is about separating responsibilities. The main, or the view in this case, the main view, when we want to display that child form, it knows what child form to use. Okay. The view model, all it knows about is what child view model to use. So this is the process that we're doing. I'll show you the code in a second, but the steps are, in my main view at startup, the main view provides my main view model with an anonymous method to call when this child view is needed. Okay, so when the main view model decides that now I need to display a form to the user, it's going to call this anonymous method that was provided by the main view. Okay, so at startup that happens. Sometime later on, that add task button is clicked, and as we'll see, all that's doing is calling a method on my view model called viewModel add new task. Okay, amongst other things over in my view model, it creates the child view model, the task view model that represents that child form. So it creates that and calls the anonymous method that was provided at startup by the main view, passing in this child view model as a parameter. Okay, so we're invoking this on edit task anonymous method. Back in the main view, the anonymous method creates the necessary child view and passes it the child view model that was provided over here in the main view model. Okay, so it's creating the form. My main view model knows nothing about the form. All my main view model knows about is the child view model. It creates the form, the child form, gives it, or the child view I should say, gives it the child view model that was provided to it, and shows it. It calls show modal or show or whatever's appropriate. When that child view closes here, the rest of the anonymous method runs. Cleans up, frees the form, does whatever it needs to, refreshes the bindings maybe in the main view. But basically that anonymous method returns back to the main view model. Okay, and at this point the main view model still has a reference to the child view model. So if it needs to reach in and grab any state or data that was created during that process, it has it. So effectively what we've got is our main view model. All it knows about is the child view models. It doesn't know anything about the forms or the views that are used to represent them. And so it effectively says, okay, create a main view, child view model. Now it's time to show this child view model. When it's done, it's got access to the child view model, so it can pull the data out. All of the knowledge of the actual user interface elements, the forms or whatever that are used to represent that child view model, are over here in the main view. Okay, so let's actually walk through that in source code. We can see, let's get some more space, we can see that my main view at startup, where are we? Here, is creating an anonymous method. Okay, and the parameters to my anonymous method are sender, and importantly, the child view model, the task view model. Okay, and in it, what it's going to do when it's called is it's going to create the child view, passing in the view model, the child view model. Okay, it's going to create it, it's going to call show modal on it, and assuming that that modal dialog closes with the OK button being pressed and not the cancel button, it's going to refresh the bindings that are used on this form, on the main form, and then free it. Okay, so pretty simple. So at startup, it's putting that, setting that anonymous method into the onEdit task property of my view model. Okay, so let's go over and look at the view model main. It has this onEdit task property. Okay, and it also has a do onEdit task procedure that takes a view model. So if we have a look at it, all it's doing is checking to see if it's been provided an anonymous method and calling it, passing in the child view model. Okay. The edit task procedure takes a task, creates the child view model, passing in the task, calls that anonymous method, passing in the child view model. It looks like there's a few hoops to jump through here, but it's a really common pattern that you'll see, where essentially the view model is driving the interaction and what child view models occur at different points, and then the corresponding views are relatively simple, thin skins that get applied over the top of it. Let's actually have a look at what is inside the view. So let's go to our task view, this child view. If you have a look at it, what does it contain? It contains some really simplistic calls over to the view model, to invoke actions and to check whether actions are invocable, for want of a better word. It has a constructor which sets up a few things, sets up a reference to the view model that was passed in on the constructor. It has some LiveBindings specific code. Okay. In this case, this is code which is essentially auto-posting. So as soon as a value is changed in the adapter, it's automatically posted back to the underlying object. You don't always want to do that. In this particular form, I wanted to do that. Some other code to set up the adapters inside my form, and that's it. Okay, so really, apart from these calls up here, okay, which are to the view model, this bit of code you could wrap up and put inside some reusable piece, the start of your view model framework that you end up creating. This form is relatively dumb, okay, and really probably, there's minimal code in here, so it doesn't really need an awful lot of testing, which is good because UIs are hard to test. Yeah. Once you've written code like this one a few times and wrapped it up inside a reusable method, then you don't have to keep testing it, really. The view model, on the other hand, for this corresponding screen, okay, this does require testing. This is where all the logic of that view is contained. So this does require testing, as does my model of my task require testing. Okay, and that's where my tests project come in. So you can see I've got, let me make this a little easier to see. You can see I've got a test project just using DUnit that has some tests for my model. So here's the tests checking whether my validating my model, and here are the unit tests testing my view models. So here's the ones that are testing, for example, this one, test can save empty title. So this one's just setting the task title to empty and then checking ftask viewModel.canSave, and checking that that's false, because as we saw before, if the title is empty, the canSave method should return false. Okay, and if it returns anything other than false in this circumstances, we're failing the test. Here's the flip side: when we've got a valid title, canSave should return true. Okay, and if it returns anything else, we fail it. We also do some testing to see whether, when we cancel an edit, whether those changes are actually cancelled or whether they still retain inside the task object. So we can unit test our model, we can unit test our view models, and get much higher test coverage across all of the logic in in our application, the only thing left untested at this point in my application is my actual view, and as we just saw, the view is really pretty simple and there's not too much in it. So this is how you get that, I was going to say side benefit, but in some ways it's not the side benefit, it's the core benefit of MVVM, in that much more of your application becomes testable and becomes unit testable. So just a few things to think about in the wrap-up. You'll run into a few of these concepts when you're reading other articles and other forum posts about MVVM, especially in the WPF world. So a few things to think about. You'll see this reference to things called pure views, and really this is just a pure view would be a view that contained no code in the back end. All of the code was off in the view model or in the model. This is a goal that's possibly not achievable, or certainly not easily achievable, but it's a worthy goal, because as we've talked about, the less code you have in your view, the less code there is in your application which is untested. So aiming for minimal code in your view is definitely a worthy goal. You reach a point where there's diminishing returns though, and trying to get to the point of having no code in your views may not be worth the effort. Okay. We also touched on this next one before, this argument in the MVVM world about whether view first versus view model first, and this is really a chicken and egg discussion. In my example, you saw that my view models came first. I prioritized my view models first, and then I created the view to match the view model. There is an approach to MVVM where you create the view first, and it is responsible for creating the necessary view model. There are advantages and disadvantages to both. I personally find that when I go view first and let the forms drive the flow of my application, I find that my applications become more complicated and more tightly bound. Your mileage might vary. So try it both ways. I decided that I was more comfortable with view model first, but try it. Another thing to think about, in this example, my views were all forms, but that actually doesn't have to be. So I was very careful to define a view as a visual representation of a view model. It doesn't have to be a form, and it's not uncommon to have a view have child views, just as like a main form could have child panels, break the layout of the form down into panels, sub-panels, and you would have a corresponding main view model that had child or sub view models within it representing each of those panels. Okay, so in your mind, try and break this connection that a view must map to a form in Delphi. A few other things. Using MVVM doesn't dictate that you use inversion of control or dependency injection, but like most applications, inversion of control can simplify things and simplify your code and your tests. So I've purposely avoided it in this example, but in real life I actually use it. I should also mention that you don't need an MVVM framework. In the WPF world and Silverlight world, dozens of MVVM frameworks have popped up. The reason for this is as you go through the process of trying to remove code from your view and write little helper functions, and same thing in your view models, push behavior up into some base view model class or something. Every time you make those decisions, you're basically starting to write your own little MVVM framework. So inevitably people end up with MVVM frameworks, even if they're the only users of that framework. So you don't need one, but you'll probably end up writing one. And then the last thing I would say about this is try it. MVVM brings a bunch of benefits. It also brings some disadvantages. There's no denying that there's more code that you have to write. The relationships in some ways are more complicated. So nothing comes for free. There are some disadvantages to this. After trying MVC and MVP, MVVM was the one that really took for me. It may not for you. So if at the end of this and after you try MVVM, if it doesn't work for you, try one of the others. Try MVC. It might take for you. Okay. Where can you get some more information? This session I'm using as the starting point for a series of more detailed blog posts over the coming months on my website. So if you're interested in more information, I will be posting more detailed stuff as I explore MVVM further over the coming months. The source code for this example is available up at GitHub, my GitHub page. There are a bunch of other resources there. That'll do us as an introduction. Hopefully this has been useful. Hopefully it sparked some thoughts. I'll leave this page up on the screen at the moment and say thank you for listening, and I'm ready to take whatever questions.
There was a question here. Have you attempted MVVM with traditional VCL, T-data source, data-aware binding mechanism?
Yeah, as I said in that, I haven't. I've been purposely. One of the reasons I've been really excited about LiveBindings, and I've been hassling Jim and his team mercilessly, is because I wanted to do this, and so I've been waiting for LiveBindings to do it. There's no reason you couldn't do it with the old the VCL data binding framework. It's not as flexible. So you know, obviously one of the limitations of the VCL data binding framework is that the source that you're binding from has to be a data set, and so you might have to, you know, mush your model down into a data set in order to bind from it. But you know, it's certainly possible. I've never tried it.
And a couple of people asked the question about the source code, and you answered that in the question and answer log, that it's all on your GitHub at http://mgrov.es/España/mvvmlist, which is the link that you have on the screen.
Yeah. So basically all of those resources that are on the screen at the moment, all the links that are up there are on my blog behind that URL that you just read out, and that is up on the screen at the moment. As I find, you know, if you Google MVVM, you'll find a million things, as you do with most things you Google. These are the ones that, when I was trying to understand this, you know, some time back, these are the ones that really I found progressed my understanding. There's plenty that you can read that may not. As I find more that sort of progress my understanding further, I'll update the blog post that's behind that short URL. But all the source is now up on GitHub. I published it while the video was playing. That link now works, so you know, grab it and play with it, I guess, if this has sparked some interest.
And the sample project you have is using exe3, right? Because somebody asked, what about exe2? I mean, you can use any language.
Yeah, well, it depends who you ask, actually. I agree, you can use any language. You'll see lots of references from WPF folks that MVVM was developed by the WPF team at Microsoft. And they did coin the name, but they basically, there's two answers to that. There are now JavaScript MVVM frameworks, for example, and in fact one of the audience members in the questions pointed out a thing called Delphi Sorcery Framework, which is a Delphi MVVM framework that I wasn't aware of. So you can, MVVM is just a pattern, so you can implement that pattern in all sorts of languages. The WPF team did come up with the MVVM name and an implementation of it for WPF, but you know, they admit this. They borrowed heavily from Martin Fowler's presentation model pattern, which also, it seems like most good ideas in the world come from Smalltalk. He borrowed that presentation model pattern very heavily from Smalltalk's application model pattern. So, you know, there's very few new things under the sun. We just keep reinventing them.
Yeah, what is MVC is, I don't know, how many years old now? It was back to the,
I don't know.
Some of the early Smalltalk days, so late 70s. Sorry.
Just while you're coughing, David, one of the things that did repeatedly come up in the questions was, you know, why did I say that the downside of this is that it takes more code? Well, And do I mean by that you can't componentize some of this? You obviously can, and that was the point I was trying to make about how everyone ends up writing their own MVVM framework. You absolutely can, but the reality is that you do have more classes to maintain. You've got, you have to jump through some hoops to get certain things done. Everyone has to make their own call about whether that extra effort, whether that pain is worth the benefit you get from increased testability, cleaner separation, ability to swap UIs out easily, that sort of stuff.
Yeah, there was a question here about are there application scenarios where you would suggest not using MVVM? And I think you covered some of that in the talk after that was probably posted as a question. But if you want to review that again.
Yeah, I mean, if it's a simple app, if it's like a utility that it's not going to get too complex and it's just there for a purpose, then MVVM would probably be way overkill. But if this is something that you think is going to have a long life and is going to need to be maintained and extended, and it's something where you definitely want testability across much more of the logic in your app. That's what I think is the biggest benefit of this, is that now I can test and do automated testing on much higher percentage of the logic in my app. All of the form logic is now very easily unit testable. If your application is complex enough to want those things, then you need to look, I think it's worth your time to look at one of the MV star patterns, MVC, MVP, MVVM, one of them. I looked at MVC like years ago, and I never really got it. I got it in concept, but it never really took. I looked at MVP, kind of the same thing. MVVM was the first one that I found sort of meshed with my brain, and also, I think one of the benefits of MVVM is that because it leverages data binding, in our case LiveBindings, you get some more of that RAD productivity that you sometimes lose in MVC and MVP.
Yeah, Lockton asked, I think you answered it, are anonymous methods mandatory? Could use method pointers instead?
Yeah, absolutely. You just need some way for the model to delegate out to the view to do something for it. It could be a method pointer. It could be a traditional event. Any of those things.
And then Gilles, I guess he had to leave, but why not merge the view model into the model? It would still be unit testable.
Yeah. And you can. Everyone makes their own decisions about how much separation they want and need. For me, there's a pedantic answer that I have, and there's probably a more practical answer. The pedantic answer for me is that then you're mixing your application model, your domain model, your domain model, which is about your problem domain. You're mixing in application concepts, view concepts, user interface concepts into that model, and then that that comes with disadvantages in terms of being able to reuse that model elsewhere outside of this particular app. So that's a downside. The other thing to realize, and I didn't realize this at first, but since I've started exploring this, I've run into customers where their model is not actually an object-oriented model. It's actually a data model. I've spoken with customers and seen their applications where their back-end model is actually they basically took their old data modules from their older Delphi applications and used that as their model, and then the view model's job became to pull that information together and present it in an OO fashion to the view. So in that case, it wouldn't make sense to mix it so much because the model at the back end was data-based. The view models were object-oriented based, and then the views spoke to the view model. So, but look, there's no MVVM police. Well, actually, there probably are, but they have no power. So despite what the MVVM police tell you, do what makes sense for your app.
Yep. I think Jared along the way was asking how to sort of map this to certain kinds of application patterns like master detail, pick lists, things of that kind.
Yeah. So in the in terms of master detail, basically the view model's job is to pull the pieces, to expose the pieces of the model that that are required by the view. to expose those out to the view. Where the master detail logic lives, the master detail logic probably lives in your model. But if you're talking about how to bind to them, then actually in this case the main view in this sample project actually binds to both the task list object, which is what it displays in that grid, and also the currently selected task, which is what binds over on the right-hand side of that view. So using the data binding, you can reach into different parts of the model for different user interface elements. In terms of pick lists, I started doing that and ran out of time, so it might be actually something that I add to this source code example. The lookup support, and Jim Tierney's been posting a bunch of blog posts on the lookup support in LiveBindings. That rocks for pick lists. It's really, I found it really easy to expose lookup lists and those sorts of things in my model and in my view model, and then bind to them using the lookup capabilities inside LiveBindings.
And there's always the question about, in many of these software architectures, what about a persistence layer? Could DataSnap, for example, be used as some form of persistence?
Yeah, definitely could. I mean, I purposely left persistence out of this because I wanted, I find that if you throw too many things into a demo, then you distract from the thing you're trying to teach. But you could use DataSnap, you could use some sort of ORM like the TMS one, and there's also that the DORM open source project, and there's the Tech Insight open source ORM for Delphi. So the back-end persistence is usually needed, clearly, but it's nothing to do with MVVM. How you want to persist your data and where you want to persist it is an important decision, but it doesn't impact MVVM.
Yep, and then Ralph was asking, wouldn't most of MVVM, I can't do that. Is there a one-syllable version? MVVM, some kind of one or two syllable thing, be implemented by simply constructing an accurate or comprehensive UML model?
Well, UML can help you lay out your model and lay out your view models. But if you're not doing MVVM, you can use it to lay out your model. But the problem that I've always struck, and that I've heard other people strike, is you build this lovely domain model in UML or whatever. So you've got this great domain model there, and then what do you do in your forms? And so do you put your user interface logic about whether this button, whether this button is valid, it should be enabled or not, or which bit of information to show at the moment, or which form to show at the moment? Do you put that in your model, or do you put it in your form? And if you put it in your form, then suddenly your form has become complicated, and really you've gone OO at the back end domain model because you wanted the benefits of maintainability and all that sort of stuff, but you've lost that with your forms. So this really just takes, maybe in some ways he's absolutely right. This just takes, if you've decided that OO is the way you want to do your model for a whole bunch of positive reasons, this just helps you stretch that out even further towards the front end, and where your view just becomes a really thin skin laying on top of your OO models. Yeah.
Yep. And then let's see, Todd sends along, great presentation. I've been trying to convince my boss of the need for loose coupling, unit testing, and the like. You've given me so much ammo for our future conversations. Thanks. Yep.
Great.
No, always good. Let's see, multiple models in one view. Let's say you want to display an order. You have a view that shows the order number, matching view model. You want to display a list of products, different model in the form. Let's see, when creating and editing the order, would the view model also have a reference to the list of products, or would you pick list be represented with a second view model that knows only about products?
This is one of those questions. I hate answers when you ask a question like this and people go, "It depends," but I'm about to do that. I'm about to do that. You can actually do it either way. Usually the decision to break up a view into, or a view model into sub view models comes down to how complex it's getting, how, all the standard things, how complex it's getting, whether you need to reuse pieces like that product pick list view model that Jared's talking about.
Yeah.
That may be something that you want to use in multiple parent view models around the place. So, unfortunately, it just depends. MVVM doesn't give you much guidance on how to, how do I say this? It shows you how to implement what you want to do in a nice separated way. It doesn't really suggest an awful lot about what you should do. So you still need MVVM's no substitute for synaptic activity. Basically, you still need to think about how you're going to break this up, where you want to create these separations, what's going to be complex, what's going to need to be reused elsewhere. All of those things still apply. This just gives you a framework for implementing it, I think.
Yeah, and Todd gets the award this time for persistent re-asking the same question. It's okay. I didn't miss it. Why did you put your model and view model into a package?
There's a couple of things in this video. Maybe I should do a director's cut at some point. When I first recorded this video, it was way too long. So there was a few things that ended up on the cutting room floor, and that was one of them. In this case, I put the model and the view models into a package because I have a half-finished Metropolis. So basically what I've done is I've got a standard Windows form application that loads that package. I've also got a half-finished one that I will finish before the C++ version of this. A half-finished Metropolis version as well that reuses the same view models and the same models and just slides different views in on the top. So that's the reason I put it in a package, so that I could show it being loaded. There's zero necessity to use a package. You could just use this, include the same files in the different projects. No problem. This example evolved, and I had grand plans about the things I was going to do at the start, which contracted as the deadline approached. So the package is just a deployment decision and doesn't really impact MVVM.
Yep. And again, I'll refer everybody to Malcolm's blog, malcolmgroves.com, where he says, yes, he will do some more detailed blog posts about this over the coming months and so on.
Yeah, basically, I've got a few actually pending that are mostly written. I was waiting. I wanted to use this as the starting point, so I didn't have to write all of this stuff up. Someone can watch this video, and then I'll go into more detail. Like, for example, the lookup list business. I've got one mostly written on that. One half written on inversion of control and how that can help in MVVM, that sort of stuff.